Hello, everybody. Today I've got a new program I want to show you, and this one has a little bit of a story behind it. So, I recently took a test that I didn't do as well on as I'd hoped, and I began thinking about just if I had only gotten a few more questions right, I could have gotten a higher score. And because each question only had four answers, and you can throw out some of them, I was like, man, if I had just had a little bit more luck, I could have gotten a much better score. And with so many people in the class, I'm sure that some people were luckier than I did and got better scores. And those thoughts kind of developed into this idea of it would be cool if I could simulate randomly choosing answers on a test and try and figure out what is the likelihood of getting all of them right or something like that on a test if you just randomly guess. Thus, we have the test simulator program. So, first, I'm gonna demonstrate it and show you how it works and what it does. And then I'll go through each line and kind of demonstrate how it works and how all that functions. So when I run it, you'll see we get this output here. I'm going to ignore these top two lines for a bit, and we're going to focus on these three down here. So this line right here, we're giving kind of an example of a simulation. So this is a test that has 5 questions. Each question has 2 options. So you can think of it as like a true or false quiz. So a 5-question true or false quiz, and 10 people are taking the test. And we can actually simulate this test multiple times. So having these same 10 people take the test 10 times, randomly guessing every time. And here we can see that the mathematical chance of winning is about 3%, which is a 1 in 32 chance. And out of all of those simulations that we just ran, about 4%, the average win rate, I call it win rate, but that just means getting all the answers right. The average win rate of all those students was 4%. So if we run it again, we have 3% this time. This time it's a little bit over 3%. So you can see we're ranging at about 3%, which mathematically is what we estimate it to be. Now, this next line is kind of representative of the test I took. So the test I took only had 30 questions, and like I mentioned, each one only had 4 options, and my class size is about 600 people. And I'm only doing one simulation because we only got one shot at the test. So when I ran this, you can see that our chance of winning is astronomically low. Like this is a super small number. And it tells us this is about a 1 in 1.1 quintillion chance. And which, with only 600 students in the class, you can almost guarantee that every single student is getting something wrong. And so the win rate you can see is consistently zero. It would be very, very rare to see this be anything but zero. So that's kind of how this program works. It just estimates what percent chance you think you'll get and then gives you a random number, and you can kind of compare how that might work in the real world. So I'm going to run through this now line by line and show you how it works. Before I do that though, if you're interested, in the description there's a link to a Google Drive folder that contains this project as well as all my other projects. So you can download that and play with it, modify it if you want, use it for whatever you need. So going through, we import random because obviously there's going to be some randomization involved. And we have this first function. It's called answer maker, and it's used to think about it as generating an answer to the test. Doesn't mean it's the right answer, it's just a potential answer set. So what it does is it takes in the number of options you have per question and the number of questions you have. And then it basically just says for each question, generate a random answer, and we're just going to put that as a number and then return that answer. So I gave an example down here. If we say it's a 5-question test with 4 answers each, you can see this time we got 44131, and that's the answer key. It doesn't have to be right, it doesn't have to be wrong. In this case, it's just an answer key. So you can see we get that. And if we could up this to say 10 questions, and you'll see we get twice as many numbers here. So it's just a way to generate an answer that we'll be using later. So this second function is to simulate a singular test. And the only difference in the parameters is that we can now have multiple people. So first, we need to make an answer key. So we do one specific answer randomly generated and assign it to this key variable. And then we're going to start counting up the number of winners. And then we say for each person, give them an answer, and we'll call it score. So this is what they got on the test. And if their score is identical to the key, that means that they got it right. So we're going to add 1 to the winners. And then at the very end, we divide the winners by people to get the percentage of winners who won. So if everyone won, we get 1, or we get X over X, and it'd be 1.000, which means everybody won. But if like 1 out of 10 people win, then we get 1 over 10, which is about 0.1, so 10%. And that is how that works. So you can see here, I represent this with, let's do the same answer, 5 questions, and 4 potential answers per question. And with 10,000 people taking the test, we only get about 0.13%. That's only 5 questions, 5 multiple choice questions where there are 4 answers each. And out of 10,000 people, about 0.13 got it right just by randomly guessing. And so you can see that getting all the answers right just by randomly guessing is really, really, really rare and difficult. So this was kind of a message to me to be like, hey, don't beat yourself up for getting things wrong every once in a while. The fact that you can work through it and get things correct without randomly guessing is honestly impressive on its own. So that's how the simulate test function works. And then for these final results, we make an average test percentage, which adds another parameter called simulations, and that's just how many simulations we want to do. So first, we are going to do some math to give an estimate of what we think the output's going to look like. So to figure out how likely you are to how many different possibilities, how many possible ways there are to answer a test. We take the number of options, so like if it's a 4 question test, we do 4 to the power of how many questions those are. So think about it like this. If you have a 1 question test with 4 options, that's 4 to the power of 1, which is 4. And that makes sense. There's 4 ways to answer that, A, B, C, or D, right? Now, if you have 2 questions, then we have 4 to the power of 2, which is 16. And that makes sense because you have 4 options for the first one and 4 for the second one. So it's 4 times 4. And then for every question onward, you just do times 4 again. So we can get this chance, and then we can print this out saying, hey, this is the percent chance you have of getting all of them right just by randomly guessing, mathematically. And then we can do, or by doing 1 over chance, we get that percentage. This chance on its own is a really big number that tells us you have a 1 in chance of getting all of them right. So we print out these little statistics just to say, hey, here's what we estimate it to be. So like in this one, we say it's about 3%. And then you can compare your result with the mathematical approximation. And then we go through the simulation. Say for each simulation, we're going to start totaling up the number of winners. So remember that this simulate test returns the percentage of people who won. And so in this case, we're adding up the percentage of people who won from each simulation and then dividing it by the number of simulations. So that's why we get the average win rate of all simulations. So that's kind of how this program works. It's not too complicated. It's a little bit of math, a little bit of programming. It's nothing crazy, but I hope you enjoyed. I hope this taught you something. And if anything else, reminds you that, hey, it's okay to get a couple questions wrong on a test. So have a great day, and I'll see you in the next video.